Hi, everybody. Like Leo said, I am coming in from New York, and this is actually my first time out of the United States. So I'm super excited. Yeah, I'm excited too. So excited to be here and super thankful for the opportunity to be able to talk to all of you guys today. I work at the New York Times back in New York, and I'm on their interactive news team. And working in a newsroom environment, working on newsroom deadlines, when you're programming on these, you're going to learn a lot about yourself as a developer. And your strengths and your weaknesses as a developer are going to be magnified tenfold whenever you're on a deadline. So one thing a while back that I had learned about myself was that I wasn't the best at debugging things. I would be on a really tough deadline, and I would have to solve a bug, and it would just be, I would just freeze, you know? So I did my homework, and I learned DevTools inside and out, and I was doing really well. But one other luxury, actually, of working on the team that I'm on is that we have a very flexible tech stack. So we have the flexibility to work with whatever kind of frameworks and libraries that we want. But as great as that is for so many different reasons, that also means you might be debugging code in a framework that you've never worked with before. But lucky for me, we have lots of different dev tools out there for all the different frameworks that we can work with. So we have Batarang for Angular. We have the Ember Inspector, React Developer Tools, and the Backbone Debugger. And that's just to name a few. And as Wyatt was saying, making debugging easier is so important for developers. So being able to use these was super helpful when I was trying to learn how to get through different bugs in different frameworks and work through different problems. And they're all kind of more or less the same. They'll have a very standard set of features. Most of them are going to provide general page and library information. They're going to display some of the current MVC data that is in the application that you're inspecting, and they're going to keep it in sync. And they're going to track some life cycles within the framework. And you might also have some performance monitoring available to you to look at those kinds of things. So any debugger you come across, these are going to be some of the core features that you're going to want to put into these things. And the fact that all of these large client-side JavaScript frameworks have these custom debugging tools solidifies in my mind that having these tools isn't just a nice to have. They're actually kind of a necessity. So whether you're open sourcing a framework, or even if you're just working on a code base at the office, or if it's something that you're working on the side, having a custom debugger tool is going to help new developers understand the framework's intentions, but it's also going to help you expose areas for improvement in your framework. So within your code base, you're going to notice if there's a huge performance hit somewhere, you're going to see it right away in these debugging tools, or someone else will, and they'll be able to fix that performance issue for you. So today what we're going to do is actually create one of these in like 10 minutes. Let's go to some code. So if you've ever created a Chrome extension before, this file will probably look familiar to you. Can people see this code? Is that good? A little bigger? So this is just a manifest JSON file, and it's just going to set some configuration options for your extension. And the only thing that makes this different than that makes a DevTools extension different than a regular one is this one property right here, this DevTools page property. And we're just going to specify an HTML page for our DevTools panel that we're going to create. But what's kind of wonky about this is we're not actually going to do anything with this HTML page except put some JavaScript inside of it. So the DevTools page isn't something that you visually need to see. It's just something that you need to have in order to run some JavaScript in the DevTools window while it's opened. And so this is our DevTools JavaScript. And The API for creating a panel in DevTools is actually super simple. We can just call Chrome DevTools panels create, and then we're going to pass in a couple of parameters. We're going to pass in a name. So for the sake of this conversation, we're going to be debugging a framework called Voodoo Black Magic. Thanks to Pedro for that name. Don't try to go looking for that framework. Don't try to put it in your projects. It's not real. So ignore that. We're going to have an icon, a URL to an image path, and then we're also going to have another HTML file, which is going to serve up the UI for our panel. We're going to have a callback that we specify, but let's first just go back to our browser and make sure that our panel is showing up the way that we are expecting it to. So when you're developing a extension locally, Chrome makes it super easy for you to load it up while you're testing it out by loading an unpacked extension. And from here, you can just select your folder with all of your extension files, and it'll add it to DevTools for you. And immediately, it will tell you if there are going to be any problems with it that are going to stop it from working. So it looks like we're OK adding this in. It's enabled. Let's open a tab and see if we have it in our DevTools. Make this bigger. Oh, no. Yikes. That's the little voodoo going on. That's what's happening there. So it looks like we got our panel in our DevTools just fine, but it looks like we don't have a Voodoo framework application running in this tab. So let's open up a tab where we do have one running. And I just made a very standard, a very token to-do application with my fake framework. And if we go to our tab, how does that look? Now we can see that we have a Voodoo application. We have some information about the version of Voodoo that it's running on. And it looks like we have some options to toggle a couple of views and inspect some of the data that we have in our application. So we're at a point where our panel is getting information from our inspected page. But before we can understand how that's happening, we need to take a look at the structure a little bit of how these are built. So a DevTools panel is going to have three main parts. The first one is the DevTools page, which we just created, where we have access to the DevTools APIs, and we can set up our panels and our sidebars or whatever UI components we want to have. The second part of the structure is going to be this background page. And again, this isn't going to be an HTML file. You can just make it a background JavaScript file. But it's going to serve as our channel for communication between our DevTools panel and our inspected page. And the way that we interact with the inspected page is through content scripts. So content scripts are, again, just JavaScript files that run in the context of the inspected window. And they're going to give us access to a shared DOM. So whenever we want to do something with the DOM or we want to get something from the DOM, we can get that information using a content script because they share it. These do have a clean JavaScript environment, though. So you won't have access to the JavaScript variables in there unless you inject a script directly into the page. So let's go back to that callback function. That we saw a little bit ago. This is how we're going to set up this channel of communication with our background page. We have access to the panel that we just created, and we're going to call Chrome Runtime Connect in order to open up a port of communication between our DevTools panel and our background page. You can optionally pass in a name for it just to keep track of what connections you have opened. And then we're going to set up some event listeners so that we can grab messages from the background page and tell our panel what to do with them. We're also going to set up a method on the window of our panel so that we can send event messages back to the background page and update the DOM or interact with the inspected page in that manner. And then our background.js file. This code is actually almost so boring that I don't want to talk about it. But really quickly, we just want to listen to this Chrome runtime on connect event. And whenever that's fired, whenever a new connection is made, we add a listener to keep track of the port that we just opened, the port of communication that we just opened. So we're just going to add these ports to an array and hold on to it so that we have a good mapping of where all of these messages should be coming and going. And then again, we're going to set up some listeners for our extension. So when we get messages from our DevTools panel, we need to send these to a particular tab. And the way we're going to do that is either by executing a content script or just sending a message. And when we send a message, we also have to send along a tab ID so that it knows where to go. I don't know about you guys, but I always have like 100 tabs opened in my Google Chrome. So if they tried to figure that out on their own, where this message was supposed to go to, it would take quite a long time. And then lastly, we're just going to handle some incoming messages from our content scripts. And we have a function down here, send to DevTools, that will send this right back to our panel so that our panel can update when something happens in the DOM or when we're interacting with our application. So let's do 2 quick examples that kind of illustrate this concept of message passing for these DevTool panels. First, let's do a message from our panel to our application. And if we look at these toggles right here, let's take the first one, for example, show view outlines. Let's say when we toggle this checkbox, we want to outline all of the views in our application so that we get information about them right on the DOM, and we can see it really clearly where all the views are and what their data is that's associated with them. So setting something like that up is as simple as putting an onChange event on that checkbox whenever we're toggling it in the panel, and then sending a message to the background page. So we set up this method earlier when we first created the panel so that the panel would know how to send something over to the background page to get it to a content script. And we're just going to give this event a name. We're going to say toggle view details. Again, we're going to pass in the tab ID so that the background page knows where to route this to. And we're just going to send in whether or not that checkbox is checked, whether or not the DOM should show this information or not. And then by the time that gets to the content script, we have a listener on our content script that's just going to check the message that was just sent. This is a little more hard-coded than it should be. But for the sake of just showing an example, I figure this is a little bit easier to explain. So once it gets this message that has information about toggling view details, we're going to call a function update view details. And this function is just going to be plain vanilla JavaScript that's going to add our view information. Oh, more voodoo, more magic. It's going to add our view information to the DOM, to each of the views that are in our DOM. So when all those messages are hooked up together, when you toggle this, we can get all this data about our views on this side. Let me make this a little bigger. So we have one view that's just our add to do view. We have the controllers that are associated with them. See if I can make that bigger. And then we have our list view, and we also have a single to-do in here at the moment. So that's how we can kind of manipulate the DOM, and you can check this and uncheck it all day long if you want to. So let's do one more example where we want to communicate from the inspected application to our panel. And we have this list of views down here in our panel that show us the current views that are on the page. And every time we add a new to-do item and we add a new view to the DOM, I want this table in my panel to update with that as well. So if you happen to look through the source code of other debugging tools, other debugging panels, everyone kind of implements these things in a very different way. There is endless possibilities for doing something like this. But basically what we need to do to get that done is make sure we're listening to what kind of data we have, what changes are happening in our data in our application. And if you're super excited about ES6 like I am, I'm just setting up an object observe on our views so that whenever a view is added or a view is changed, we're going to call this dispatch change messages function or method. So we're adding this method directly into the framework. As long as this code is injected into the application page, we'll have access to add this method directly to the window or directly to our framework. Obviously, we should be doing a check to make sure that it is not already there, it doesn't already exist. But when it does this, we're firing a new custom event called data change. And we're going to dispatch that on the window. So every time that happens on the window, our content script is going to be able to listen to that. And every time that happens, we'll send a message to our background page saying that some data was updated. What should we do with this? And going back to our background page, we know whenever we get these messages from our content scripts, we're going to send them right over to DevTools to let them figure out what it is, what kind of message it is that came in, what they want to do with it, and how they want to react to it. So when this message comes in, let me find this. When this message comes in and it makes it to our DevTools panel, we're going to try to handle this inspected window element. Or event. We're going to handle an event that just happened in our application. And again, this is more hard-coded than it should be. But we're just doing a check to see if the event was an added view. And if it was, we're going to update this views list that we have. And the function here for this, all it's doing is grabbing the most recent view that was added in our framework and appending it to the table that we have in our panel. One thing to note about this code is this line right here. You'll notice it says eval, and we're all very scared of eval. We're terrified of that, right? But when you're creating a DevTools extension, you're almost always going to need to use this at least once. Your DevTools panel has limited access to the inspected window. So like I mentioned before, we can get the tab ID of the inspected window. And the only way we have access to the JavaScript on that window is through an eval. So you have to be really careful using this. And you have to know what you're doing with it, obviously. But this is why when you install an extension, it might be asking for like 1,000 different permissions. And it sounds terrifying to install it. But that's because that's how powerful this is. But we need to use this eval so that we can get our object of views that is currently in our framework and pass that back to our panel. So when this is all hooked in and we have our most recent view and we have that data available to us, every time we add a to-do, it should add to the bottom of our table right there. I have a lot of lorem ipsum memorized. I can continue doing this, but I'll stop. So those are just two very trivial examples of how we can communicate from our panel to our inspected page and vice versa. Obviously, you can do a lot more with these things, and debugger tools are a lot more comprehensive than something like this. But that concept of message passing is what you really need to get a hold of in order to build something full on for a debugging tool. Hopefully, this gives you guys some ideas about tools that would be useful for you or things that might be helpful for you when you're debugging. And we will, there's tons of like documentation and really great stuff on the Chrome website to help you start building out some of these. I would also strongly recommend looking through the source code of other debugger tools, because they're all pretty involved and have good examples of how you should build these things. Presentation is this second link. Second link to the bottom. I'm Brittany Storoz everywhere on Twitter, on GitHub, and I will be posting the code to this on my GitHub, hopefully after lunch. So look out for that when I tweet that out. And thank you guys.